My name is Emily Chaudhary. My bearing ID is 12208011. I am a student of the Computer Science and Engineering Department of Kumila University. Firstly, I would like to thank our honorable course teacher, Dr. Mohammedul Hassan, Associate Professor, Department of CSC, Kumila University. My presentation topic is queue implementation. Now, I will discuss about the queue. Definition: a queue is a linear data structure that follows the FIFO principle. This means the first element added to the queue is the first one to be removed, similar to real life line or waiting area. Now I will discussing I'll be discussing about the characteristics of a queue. FIFO. A queue operates a FIFO basis, meaning in the first element added is the first to be removed. Main queue of operation. Enqueue adds an element to back of the queue. Dequeue means removes an element from the front of the queue. Peak views the front element without removing it. Is empty, check if the queue is empty or not. Now I will be discussing about the types of queue. Number one is simple queue, also known as a linear queue. It implemented according to the FIFO method. Example: a line of customers at a checkout counter. Number two, circular queue. The last position is connected back to the first position to make a circular queue. It utilizes space more efficiently because it reuses the position of the array that have been freed up. Example: round robin scheduling in operating system. Number four is priority queue. Priority queue means elements are dequeued based on their priority rather than the order they were enqueued. It can be implemented using heaps or linked list. Dequeue. Dequeue means a double-ended queue. It allows insertion and deletion at the both sides. It can be implemented according to FIFO or LIFO method. Now I will be discussing about the I will be discussing the algorithm of queue implementation in queue. Let's begin the process. In step 2, it check the uh, queue is empty or not. If front equal to null, that means the queue is empty. Then it's go to the step 3, set front and rear equal to 0. If it is not, then skip it and go to step 6. And step 4, set the element in the rear. And step 5, go to step 10 to stop the process. Step 6, it check if the array if the queue is full or not. If rear equal to max minus 1, that means the queue is full. And it go to the step 7 and display the message queue is full, and go to step 10 and stop the process. And step 8, uh, step 8, it increment the rear one and set the element to the rear. Step 10, it move to step 10, stop the process. Go to step 10 and stop the process. Now I'll be discussing the algorithm of queue operation, dequeue. Step 1, we will begin this. And step 2, it check the queue is null or not. Is queue is empty or not. If front equal to null and rear equal to null, that means the queue is empty. And then go to step 3 and display the message queue is empty, and go to step 10 to stop the process. If it is not empty, then go to step 4. If front equal to null, front not equal to none, and front equal to rear, that means there is only one element in the queue. And then go to step 5 to remove this one element and set front equal to rear equal to -1. It means there is no element in the queue. In step, if it is not, then go to step 8 and set I equal to q, and step 9, then return the delete element of I. And step 10 is stop the process. Now I will be discussing about this diagram. This diagram represents the boxes in enqueue. Enqueue means insert the element in the rear, and dequeue means delete the element in the front. The leftmost side boxes marked the front. That means it represents the front of the queue, and the the rightmost side boxes marked tail. That means it represents the rear of the queue. uh, if 2 is deleted from this, then 3 becoming the new front. And similarly, if 9 add to this diagram, and then the new rear is will be 9. Now I will be discussing about the source codes of queue implementation. This is the source codes of queue implementation. There is three main function, that is enqueue, dequeue, and display queue. If user input 1, then it calls the function enqueue. Enqueue means at the element in the rear. It discuss in previous slide. If the user input n equal to 2, that means it calls the function dequeue. Dequeue means remove the element from the rear. It also discussed in previous slide. If user inputs n equal to 3, then it calls the display queue function. If this display queue function print all the element from rear, front to the rear. uh, and it also checks if the queue is empty or not. If the queue is empty, then it displays the message that queue is empty. Now I will discussing the queue operation complexities. In n queue operation, time complexity is big of n, and space complexity of big. And overall time complexity of queue operation is big of n, and overall space complexity of queue operation is big of n. Now I will be discussing about advantages and disadvantages of queue implementations. Advantages: simplicity. The queue data structure is simple and easy to understand. Order preservation. Queues maintains the order elements. Efficient memory utilization. Circular queue makes the efficient use of memory. And disadvantages of queue: a fixed size limitation leads to increases the complexity in dynamic memory management. A sequential access uh, making searches inefficient. Thank you everyone.